So today we are on the back side of our 6.6 notes. We're talking about something called compositions of functions. Okay? Compositions of functions. And for compositions of functions, it sounds complex. And when I start explaining, it's going to kind of look complex. But really, all I'm doing is I'm telling you how to shop. That's it. This is a lesson on shopping. Okay? This is a lesson on shopping. So what this lesson is talking about basically is if you go to a store and you're wanting to buy a shirt for $100, don't ever buy shirts for $100. I mean, that's beside the point. If you want to buy a shirt for $100, okay, and it says that you have 40% off. So you're like, sweet, how much am I spending? 60 bucks. 40% off of 100 would be 60 bucks. Okay. And then there's another sign up at the register that says, hey, at the register, take an additional 10% off. Sweet. How much do you think you're spending? $50. Okay, so you're saying that the 40% and the 10% add up to 50%. So 50% of 100 is $50.
No, it wouldn't equal. You wouldn't get 50. Yeah, you get 10% off of what you already have left.
That's the point. You are actually not getting 50% off. Okay? They're taking 10% off of the already reduced price. So let's talk about that as a composition of functions. Okay? So let's first talk about what is a composition of functions, and then we will work our shopping problem. So, composition of functions, this is the important part you need right here. This, you've got to understand what's going on there. Okay? Just like the back side of our homework from yesterday, where you were doing like g minus f of 2, right? You were then supposed to find g minus f, that function, and then you were supposed to substitute 2 in for x, right? Because that's what our function notation means. If I have f of 5, that means I take my f of x function and I substitute 5 into it, right? Okay. Well, therefore, if I have g of f of x, it literally means I'm taking the f of x function and I'm substituting it in to the g of x function. Okay? That's what we're doing there. That's what it's talking about. So it's written this way. And by the way, this is extremely important that you pay close attention to the notation. Okay? That symbol in between the G and the F, that is not a dot. That's an open circle. Okay? It is not a dot. It's an open circle. So you've got to know that it is not the same thing as what we saw yesterday. This is not the same as this. They mean two totally different things. Okay? The way we read this is we read g of f of x. The little o is like of. Okay? So g of f of x. And what does g of f of x mean? It means that we're taking the f of x function and substituting it into the g of x function. The way I like to remember that whenever I'm working these problems, I look at, let me zoom in here. I look at what they're asking me to do. So right here I've got g of f of x, and I say, all right, let's just add another set of parentheses there. And so now it looks like that. Now I can see what I'm doing. I'm plugging f of x into g of x. Okay? So, that's the first thing we need to know, our notation. The second thing we need to know about this is the order in which these things are calculated. Okay? By saying g of f of x, by saying this, which means this, of course, that really means that I am first doing the f of x function. Okay? Then, whatever I get for an output, that's then going into the g of x function. So I'm first calculating the f of x, then I'm calculating the g of x. Okay? As kind of a visual on that, what we're doing for the g of f of x function, that means that we are taking an f of x function, which we have an input for x, right? We input that. It's going to output a y, right? Input, output on a function. Well, that output of the f of x function is now going to be dumped into the g of x function. That is now the input of the g of x, which then dumps out our output. So each individual function has an input and output, but together, if we have our input starting here and coming out over here, that is then the input and output for this composition of functions. It's going through two different functions. Okay? So, sounds kind of confusing. Actually, it's not too bad. Let's look at an example before we look at our shopping example. Right here, composition of functions. They want us to calculate g of f of negative 3. Okay? So the first thing we need to do is we need to find g of f of x. Okay? So, I like to put my little parentheses here. Okay, that tells me that I'm taking my g of x function and I'm substituting into it my f of x function. Okay? So what is the g of x function? Look at the problem. What's the g of x function? X squared. So I'm going to take x squared and I'm just going to write it as parentheses. Anytime I see an x, I'm going to write a parenthesis. So I have x squared. That's my g of x function. Okay? Okay, so we have our g of x function written down. Now I need to substitute my f of x function into it. And f of x is x minus 5. So I'm literally plugging one function into the other function. I am taking my f of x function and I'm plugging it in for x in my g of x function. Okay? And that's it. Now I can FOIL that. Now I can take x minus 5 times x minus 5, which is x squared minus 5x minus 5x plus 25. So x squared minus 10x plus 25 is f of x. Well, that's really not what they wanted us to find. They want us to find g of f of negative 3. So what we need to do now is plug negative 3 into our function. G of f of negative 3 is negative 3 squared minus 10 times negative 3 plus 25. So 9 plus 30 plus 25 gives me 55 plus 9 is 64. So let's take a look at that shopping problem I was just talking about. If they tell us that we get 40% off, then 10% more off, okay? What we're going to do is we first need to calculate 40% off. That's going to be our f of x. To calculate 40% off, we take the price of the item minus 40% of the item, right? So if I simplify that, I'm actually paying 60% of the cost of the item. Well, my g of x function is going to be that additional 10% off. So I take the price of the item minus 10%, which is then 90% of the item is what I'm paying. So to find g of f of x, I take my g of x function and I'm going to substitute my f of x function into it. Okay? Because remember, the inside function gets done first. The inside function gets calculated first, then the outside function gets calculated. So, what is 0.9 times 0.6? 0.9 times 6 is 54. So, rather than saying I got 40% off and 10% off, so I get 50% off, actually, I'm getting 46% off. because this means g of f of x, the way this is written means I'm paying 54% of the cost. So it's actually 46% off, because I'm taking the additional 10% off of the already reduced price.